All right. Well, thanks everyone for joining. That was a really interesting poll. And I'll talk about that a little bit later about how that pretty much aligns to what we're seeing uh, in the field and kind of what affects those ratios a little bit. Looks like we got a lot of attendees today. I don't know what the average attendees is for big data, but looks like we got a lot today, and that's great. I appreciate everybody for joining. So as Paco mentioned, let me scroll through here. Hold on. All right, my name's Scott Shaw. I'm a solutions engineer for Hortonworks. You can reach me at sshaw@hortonworks.com, and my Twitter account is ShawSQL. I don't do a lot of tweeting, but then again, I don't tweet a lot of pictures of my food or personal things. So it's mostly, if I tweet, it's usually about events or big data or things like that. So I try my best, but feel free to follow me, and I'll certainly follow you because I get a lot of good information from others on Twitter. So again, as Paco mentioned, I've been a SQL DBA actually until about 6 months ago. I was a SQL DBA for almost a decade. I was also a Microsoft BI consultant around SQL Server architecture, as well as analysis services, dimensional modeling, SSIS, ETL, all that good stuff. I speak quite a bit. I'm actually, if you notice the upcoming schedule for the presentations, there's a gap there in November, and that's because I will be presenting at PASS, which I recommend everybody try to attend. It's a great time. I'll be presenting on this same topic actually, but I think I'm going to dive a little deeper. It's going to be a level 400 course, so presentation. So I'll try to dive in a little deeper during Summit. Should be a lot of fun. Plus, we have more time. So the goals of this presentation is twofold. One is to understand Hadoop and the role Hortonworks plays in the Hadoop ecosystem, as well as to understand the partner relationship between Hortonworks and Microsoft, which can be quite confusing at times. Especially I've co-presented with Microsoft at a number of SQL Saturdays, and people tend to be confused about that partnership. I want to try to explain it here. So if you have any questions, put them in the chat. If we can't get to them, I'll answer them, but always feel free to email me directly with any questions in general. So with that, I guess we'll go ahead and get started. So a lot of times I'm asked, why now? Why big data? And what I try to explain to people is that it's not us, as a company, Hortonworks, that are changing, that are forcing this upon businesses. It's that the data is forcing businesses to change. And we see that very early on with the companies that created or engineered Hadoop to begin with the Yahoos and the Googles, is that they had to change in order to survive as a company. They had no choice. It was change or die. And so what we're seeing is we're seeing as the data changes, as it gets into the more away from your traditional transactional relationships into more the interactions and the observations type of data, that not only is the data growing, but the type of data is changing. And that type of data doesn't fit naturally into your traditional data models like SQL Server or even a traditional data warehouse model. We call this thing, as you build towards the big data layer and the petabyte layer, the observations and stuff, we start seeing the the influx of things like sensor data, geospatial data, image data, clickstream, data like this. If you follow big data at all, I mean, you've heard these terms about variety, volume, velocity, and things. And that's really what we're dealing with. And, you may be having some of the same issues at your company and looking at some of the data that you just haven't tapped into yet. And that's kind of where we start to come in with the Hadoop solution to discover how we can tap into this data for analysis. There was a recent article that said 90% of the world's data has been created in the past 2 years, and that's only going to increase going forward. The obviously the data chart, the chart for data growth never goes down. It always goes up. So what are some of the problems with the existing processes? Well, if you've been in BI for any amount of time and worked on BI projects, this is pretty much what you see, right? You have the existing sources, and they feed into your traditional relational systems, usually in the form of a staging database. That feeds into an EDW, or you feed it into a appliance like PDW, or now APS, as it's called. And from there, you do the analytics. So this is common. Now, the challenge again is that, let's say you want to add additional sources, and they don't even have to be streaming sources or geospatial or geolocation sources or server logs. They could just be another relational database. The complexity, that the way you have to change the ETL to account for that additional source causes exponential complexity and time. So anybody who has done kind of any ETL work, the second you start bringing in additional data sources and fitting those data sources into the ETL design knows how difficult it is. And even Kimball says that ETL is over 80% of BI development. So there comes a time where we start to leave data on what we say on the cutting room floor, as Microsoft has put it, as data exhaust. This data just lays there because we can't fit it into our traditional ETL process. It's too difficult, it's too expensive, and it's too slow. Because a lot of times with the ETL, they're very time sensitive. So we may have a certain amount of time to process the ETL and another amount of time to process the cube for analysis. So, and this is only getting more difficult. So so another factor that we also see is that this ETL processing is occurring on the same systems that house your data warehouse. So your staging database is also existing on a relational database like SQL Server, and using the hardware and the compute and the processing of your SQL Server systems. It's using the licensing of your SQL Server systems. And many times it could be competing, with the same resources as your EDW. And sharing those resources can cause a lot of performance issues and problems. And it's not really optimized for that. I mean, you want your higher end, expensive, MPP hardware to do what it does best, which is the analytics, which is the crunching of the data as fast as possible in near real time. You don't want to have to use it to cleanse data or to move data around or run aggregates or merges or anything of that nature. So that's just a waste of resources. So where does Hadoop fit into all this? Well, what we see for Hadoop is we see Hadoop more as a staging area. So now, as your data sources come in, you have a choice. You can put the data, either continue your current ETL process and ingest them into your RDBMS or EDW or MPP appliances, or you have the option to stage them in something like Hadoop. And this is something we stress a lot in Hortonworks, is we're not a rip and replace company. We're not out to replace your RDBMS or your EDW or MPP. I don't think Microsoft would be partnering with us if that was our message. Our message is an integration, that we give you choices as you bring in your data sets, and that data is no longer it no longer sits around. You can move your data around. You can ingest it into Hadoop cost effectively. Literally pennies on the gigabyte. And then from there, you can cleanse it. You can do your traditional ETL using some of the tools like Pig and Hive, and then move that database from Hadoop back into your relational systems, or not even relational systems, mostly your EDW systems or your APS or PDW appliance. and move them back and forth and really optimize the use of those appliances in those very expensive or critical server resources for Hadoop. And the reason why this is, reason why you can do this, because Hadoop was designed to hold massive amounts of data in scale, redundantly, and cheaply. So failure, one of the tenets of Hadoop is failure is an option. So as you scale out your Hadoop cluster, and get into the hundreds of nodes, or in the case of Yahoo, the thousands, the tens of thousands of nodes that they have, at any given time, servers are going to fail, and that's okay. And actually, the story with Yahoo is what they do is when a server fails, they don't immediately go in there and replace the server. What they do is they have a maintenance window where they'll go ahead and replace 100 servers at a time, or hundreds of servers at a time, and they'll do it in bulk. They'll just let the servers sit there dead, or they may be drives that are dead, or entire servers or entire racks that are dead. They'll let it sit there, and then every once a month or so, they'll come in and they'll just replace them all. That's much different than if you're running ETL and your SQL Server dies in that ETL process. Everything's going to die. A drive goes out, something of that nature. I mean, the system stops. And then as a SQL DBA, an operational person, you get your midnight call saying, the cubed-in process or the ETL broke, and you got to go in there and fix it. That's not the world of Hadoop. Hadoop is great about once you get it up and running, once you get HDFS up and running, it continues to run very efficiently. What's also nice about Hadoop is that, and coming from the SQL side, it scales linearly. So it's very easy to predict your compute and your costs too. So let's say you have a small cluster, you have an 8-node cluster, and a job runs in 10 minutes. And you want that job to run in 5 minutes. Well, it's very easy to compute. You just double the size of your cluster and the job will run twice as fast. It literally is that linear to scale. And your cost scales linearly too. So, what it's going to cost per server to scale up. Makes life a lot easier for the administrator. So there's the integration, there's the ingest of these sources, and also what's nice is that it's easy to add additional data sources in Hadoop. And that's because, and this is the dirty little secret of Hadoop, is that the ETL, that T part of ETL, the transform, is not done done before the load. So I like to call it ELT with Hadoop. So you do extract, load, then you transform, as opposed to extracting, transforming, then loading it into the system. This is a fundamental paradigm change in this model. It allows you then to not worry initially about the data you're ingesting. And since your storage costs are so low, you can sometimes it's more expensive to figure out which data you want to remove than to just go ahead and ingest all your data and then only worry about schematizing that data, called schema on read, when you decide to use it. That's really the fundamental shift we see in this data ingestion problem that's we're finding. So that allows those multiple sources to be brought into Hadoop without worrying about how they're going to be structured. You will have to worry about structure on read, but at least you have the data stored and you can look at it much more closely and only structure that data you think is necessary for your analysis. So how does a company start their Hadoop journey? And this is where we'll kind of go back to the poll. So what we found is that a company will be doing research, which over 67% of you are in the research phase. And what that usually means is that you'll be looking around your company. You obviously heard about big data, this thing called Hadoop and what you can do with it. Well, So you might, maybe it comes from the business side, maybe it comes from the IT side, but it's really not that much different than your traditional BI problems. So in a BI project, you start to think what questions you want to ask. Maybe you already have some reports you're running that you want to reproduce, but maybe you want to add some additional data that you don't have access to yet. Maybe there's business users that are asking questions that they just can't answer using your traditional relational BI process. So you start kicking around, you start doing the research, and you say, well, this Hadoop thing might be interesting. And then you kind of get into the evaluation phase then, which is, you download the sandbox, you build a small cluster, you maybe talk to somebody from, talk to a vendor like Hortonworks about some of your options. And this is typical, but what's great about Hadoop, especially our distribution, is that we're 100% open source. So there literally have been companies that have started their Hadoop journey by grabbing desktop servers from a closet and networking them together, downloading Hadoop, installing it, running it, and now they have millions of dollars in cluster and revenue generating processes going on, analysis. So it really is that easy to start. I mean, it's open source, it's free, there's no licensing costs. The strange part about working with a company like Hortonworks is that we don't even know all the people that are using Hadoop and using the product because we don't track it. There could be, we only know that Yahoo is the largest cluster in North America. But beyond that, we don't really have insight into the other companies that may be using Hadoop at scale because we don't track that. We're a software company that doesn't have licensing, but that's fine. Because it's a journey for a lot of companies as they start to build out their infrastructure. So we really see two types of use cases deriving from Hadoop, and that is the enterprise business groups. So things, maybe finance has some use cases, supply chain has some use cases. I do a lot of work in healthcare, so healthcare will, they may be looking at clinical documentation, maybe vital sensors, things like that. So they start bringing up these use cases. The other use cases, which tend to be even more prevalent, though that's slowly changing, is the operational use cases. So these things are like network traffic, security issues, and probably the most common use case we have is ETL offload. As we mentioned before, moving from a traditional ETL to ELT scenario. So there's your business groups, there's your business use cases, and your operations. Still, there is a lot of work in the research and evaluation part before you get to that POC stage, which the POC stage is when you've defined a use case. It may not be the use case that you're going to go forward with, but it's certainly the low-hanging fruit. It's the analysis that you feel like you can get the most bang for the buck. And what we tend to do is we tend to involve a ideation session where we get business users, we get IT together, and we determine those top 2 or 3 use cases that have the highest value and highest feasibility. And I assume that some of you have already gone through this process, at least maybe 5% of you have gone through this process, and have already determined what use cases provide that. I'd be very interested in hearing some of your stories around that. So a word of warning is, so what happens during these ideation sessions and once a use case is proven out? What we've seen time and time again is that there becomes this exponential growth, and this is what we refer to as the data lake, is that once a company starts to realize the value of Hadoop and the ease of moving data and staging data into the Hadoop environment and the cost savings of doing this, you begin to get this data lake where Hadoop then becomes this platform for staging your data. And now word gets out, and it literally does get out in an organization that, oh, we can start bringing in this data and that data and this data. And business users start asking more and more questions, and you start to see barriers between line of businesses break down. You've seen this time and time again at very large organizations. So your half dozen use cases originally start to swell to 20 or 30 or even more. You still go through the same ideation process. You still determine who has access to the data, how the data is going to be used, resource capacity, things like that. And this is a long journey. It's not something that happens overnight, but we've seen it time and time again that the value of Hadoop is the ability to mash different types of data together to derive better insights. So obviously, if we go from 20 to 30 lines of businesses all wanting access to data, we start to have to think about how Hadoop fits in with the current data center. And this is really where we start to see our core partnership with Windows. So Hadoop, Windows, Microsoft was a very early partner with Hortonworks. Actually, the story I've heard is they were partners before Hortonworks was even officially a company. And I remember going to Summit 2011, I think, or might have been 2012, and seeing a large Hortonworks booth. And I had no idea what it was. It was brand new, had no idea, but Hortonworks and Microsoft have been close from the very beginning. In fact, Microsoft originally had their own Hadoop distribution that they developed in-house, and they dropped that work in order to partner with Hortonworks. But what this allows is the main tenet of HDP 2.1 is this integration with your current data center. We would be naive to think that as a Hadoop platform and this transformative platform that we could just throw ourselves into a data center and rip and replace everything and not care about operations or security or data governance and things of that nature. So what we've worked hard to do as a company, and that's one of the reasons why we're 100% open source, because we feel like partners like Microsoft are more willing to work with an open source company like Hortonworks, is to create these connectors and these plugins into the platform, and so that it's transformative from a business sense, but isn't disruptive from an IT sense. Since HDP 2.1, we've really started to see the movement of Hadoop as a serious platform as a serious enterprise platform begin to move away from the coast, the Silicon Valleys and stuff, away from the coast and more towards traditional enterprises. The big Fortune 500s and things like this, the banking, the financial industries, the healthcare, all this. We're starting to see this more and more. And I think the amount of attendees on this call is a testimony to that fact. So it's a really exciting time for big data and Hadoop in particular. So then, so we actually call this integration, we call it the 5 boxes. So if you see in this diagram, we have governance and integration, we have data access, we have security, operations, and data management. And a lot of the names and features that you see, like Falcon, Scoop, Yarn, Knox, things like that, and Bari, they all fit into one of these boxes. And each box is a way to standardize the Hadoop platform within your current data center infrastructure. So how does Microsoft fit into this? Well, this is really the seamless integration of Microsoft. And this is what I think is really exciting, especially coming from a Microsoft background, is that you can run Power BI directly against HDFS on Hadoop using ODBC. So you can pull data into Hadoop, you can structure it using Hive, you can cleanse the data using Pig, structure it using Hive, and then you can access, well, actually particular HCatalog, which is the schema meta layer, and then you can access HCatalog using Power BI, and you could run your same Power Pivot, cubes directly off from Hadoop. On the other side, you can also integrate the Hadoop data with SQL Server and then run your Power BI off SQL Server. Even more so, you can, if you have an appliance, an APS appliance, the APS includes the Hadoop distribution, and from there you can run SQL queries on the appliance and use Polybase, which allows you to connect to both Hadoop and SQL Server without knowing the difference. They connect as a single single source of data. And then on top of that, you throw in HD Insight and Azure. So Microsoft recently has really, in our partnership with Microsoft, we've seen a lot of changes in Microsoft, and Microsoft starting to open up into the open source platform. So one of these changes is the idea of Azure. So you can create a Hadoop cluster in Azure, but you can create a Hadoop cluster, a Hortonworks cluster in Azure using either Windows servers or Linux servers in Azure. And Hortonworks is the only distribution that runs on Windows. So not only that, but you can also spin up an HD Insight instance in Azure. And HD Insight behind the scenes is also running the Hortonworks platform. So it's this extremely tight integration between Microsoft and Hortonworks that allows you to bring in a technology into your enterprise with not a lot of IT disruption. The other component too to notice is that we do offer SCOM management packs for Hadoop. So lots of options here. So when do you want to use which? Because again, we say, we're not ripping and replacing this. So here's a quick slide, and you can refer to this later when the slides are made public, that it's really a spectrum. One thing Hadoop will never be, and will never claim it be, is an operational data store. We have no intention of making Hadoop into your traditional SQL Server, gears of the enterprise type operational, transactional, OLTP type data store. When we discuss later things like Hive and Tez and some of this in more interactive queries, we're still talking about data analytics. We're not talking about replacing OLTP systems. I don't think Hadoop will ever get there. I don't think it needs to get there. It's not what our purpose is. From SQL Server, then you go to the EDWs, which is a little more denormalization. You may run analysis services for faster compute. Then you have your appliances, which are for very, very fast compute. Again, you're going to get faster analytic compute on APS than you will on Hadoop. DocumentDB may be new for some. DocumentDB is actually Microsoft's new NoSQL database. So it's a document store database, kind of like MongoDB, just released recently. And then finally, there's HDP, which is, again, it's very loosely structured. It's immutable data. It's really for data discovery, data mashing, very fast writes, as well as very fast sequential batch reads. And also highly, as you move to the right here on this scale, you're also getting more distributed. So we have choices. Again, you have a choice. You have Hortonworks HDP for Windows that you can run on Windows servers. We have we're available for Server 2008 as well as 2012. HD Insight, again, HD Insight is excellent for getting, if you are doing a POC or an evaluation and you have Azure credits, I recommend spinning up HD Insight to get started very quickly. There isn't, Insight doesn't provide all the functionality that the traditional HDP for Windows would provide, though in most cases, HD Insight will provide you the functionality you'll need to get started. So it provides Hive. They recently adopted HBase. Storm is in the works. So you should be able, for basic POCs, HD Insight will work well for you. HD Insight is also excellent for seasonal compute. So it separates the compute from the storage. So if you're not using compute, you spin it down, but your data stays in the cloud. And then finally, there's APS, which is great for scale out appliance, very fast analytics, an excellent choice if you want the highest performing analytics available on the market. Again, no matter which solution you choose, it's all runs on the Hortonworks and it's co-engineered between Hortonworks and Microsoft. And we'll talk about in a little bit. I'll just point out Falcon, which will allow you even to go from on-prem to the cloud seamlessly to move your data. So from a very basic standpoint, what we provide is we provide a core platform. We provide the HDFS platform as well as what is new for HDP 2.1, which is this concept of yarn. Now, traditionally, Hadoop was a single-use system running batch. So you had compute, which is MapReduce, and you had storage, which is HDFS. It was batch oriented, which simply means you submitted a job. That job took up the entire cluster resource until it finished, and then the next job could run. Very inefficient when you're talking about a data lake and bringing in multiple lines of businesses. So what you had is you then had, if finance wanted to do work, then finance would have their own cluster. If supply chain wanted to do work, then supply chain would have a separate cluster. So you had all these different data marts, cluster data marts throughout your enterprise. What Hortonworks created then in open source was Yarn, which means yet another resource negotiator. Why they called it that, I'm not sure. My thought was, if you look on Yahoo, because it was developed by Rune Murthy, who was Yahoo engineer and co-founder of Hortonworks. Yahoo, according to Wiki, actually stands for yet another hierarchical officious oracle. So they must be playing off the same yet another theme from the Yahoo, but I don't have any proof of that, but it was interesting. So what happens is Yarn then becomes this operating system for Hadoop. Think of Yarn as a resource governor, in SQL Server. So it allows then for multiple data access patterns. So if you have one job that runs as batch, that's fine. It can run side by side with another job that runs interactively, as well as another job that's real time. And neither one of them, each of those jobs will run in separate containers that won't take up the entirety of the cluster resources. And it does this through something called preemptive scheduling. So preemptive scheduling is the ability to assign resources to different jobs. So you say, well, this job or this group, actually, you can assign it to user groups. This group can have 30% of the resources, or this group can have, and this other group can have 70% of the resources. So it allows you to divvy out the resources for a cluster. So now you get this concept of a data lake where you have a single cluster facilitating all the analytics in an enterprise. We like to refer to as Yarn as the operating system for Hadoop. And this gives you kind of an overview of it. So now, as you see, you have the Yarn, and then individual data access points, including things like in-memory, graph streaming, interactive, real-time, um, all fit into, can run natively in Hadoop on a single cluster and work well together. Not a single, neither one of those data accesses will take up all the resources in your cluster if you configure it correctly. The idea ultimately, and I've heard this, right, is that at some point maybe there could be like a Yarn app store where, because again, this is all open source, where third-party companies will write applications that plug into Yarn and then can run on your Hadoop cluster. And you could go online and purchase these apps or download these apps and plug them into your cluster. So let's take a quick look, high-level view of some of the interactive querying that Yarn allows. I know this will be dear and near to the SQL folks out there. So I'm sure everybody has heard of Hive. So Hive is the SQL query language for Hadoop. Now, originally Hive runs MapReduce. So traditionally, Hive runs directly against MapReduce, which MapReduce is batch. So Hive queries would take a long time to run. What we're seeing now is a community development to make Hive faster and more interactive. In order to do that, we start to move away from traditional MapReduce and more towards a TES engine. Querying engine. Now, we're not getting rid of MapReduce. MapReduce is still very vital to the Hadoop ecosystem and it's still fully supported. But for customers that need interactive querying, then as well as batch, we provide now the TES engine, query engine. What's really different about this is a couple things. One is that this is querying at terabyte to petabyte scales. So are we going to be as fast as traditional SQL, where you have your traditional indexes and optimize relational optimization for the query engine? No, but then again, even with those relational optimizations, you're still going to have a lot of trouble querying petabytes of data. Something that petabyte of data in TES may take an hour or so, where it could take a day in traditional SQL. So we are talking queries at scale, terabyte to petabyte queries that return data in a very reasonable amount of time, an interactive amount of time, as opposed to batch. What we also see then too is this, which is really exciting, is the development within the open community, where, and this is why we believe so strongly in open community, is that if you look down at the bottom, there was 145 different developers that added code to Hive, over 390,000 lines of code. Those 145 developers were from 44 companies. So those companies include Yahoo, Facebook, Netflix, and actually Microsoft. So Microsoft contributed quite a bit to the Stinger initiative. They contribute optimizations around org files, and they also developed optimizations around vectorization. So this is critical, I think. When you compare it to proprietary solutions, proprietary solutions that may have 25 developers from a single company or something, they can't compete with the open source for innovation. And the innovation speed is just phenomenal for this. And we see this both in the development of new even since I've been at Hortonworks, I've been working with big data for a little over a year. The environment is completely different now. Hive, if you did things on Hive, a year ago or even less, even 6 months ago, you were limited. But now with the Stinger initiative and HDP 2.1 and Hive 13, the amount of the the similarities between your transactional SQL and your HiveQL is the gaps closing. Now, HiveQL, keep in mind, HiveQL will never be the same as T-SQL, and it doesn't have to be, because remember, we aren't trying to replace your relational systems. We're just trying to optimize analytics functionalities. So you're not going to see triggers in Hive, because there's no use to have triggers when you're dealing with a data warehouse type environment. It's not needed. So you won't see all the functionality ported over. We won't be, ANSI compliant, but you will see, hopefully at some point, all the necessary analytic functionality in Hive that you would get in traditional Transact SQL. And we're seeing this, which was recently announced, the Stinger.next initiative. So this is really exciting. And and again, if you come from a SQL background, you're going to be extremely excited about this, is we'll actually bring in ACID compliance with Hive. So that means, yes, you can update, insert, and delete data on Hadoop. So there's that. There's also the a cost-based optimizer that's going to be introduced. Other things is more analytics. So things like non-equal joins, set functions, union, accept, and intersect, interval types, subqueries, nested and otherwise, as well as analytic syntactical things like rollup. So we'll begin to see, and if you want to dig in further, there's more information on the Hortonworks website to dig in further into this. Another interesting part is the cross-geo queries. So if you have a Hadoop cluster, multiple Hadoop clusters geographically dispersed, you'll be able to run one query to access all your clusters. Other things, materialized views, which will be allow storing multiple views of the same data, and those views can be held in memory. So a lot of interesting things, a lot of exciting things coming up in the next 6 to 8 months. So what is this going to mean for the larger ecosystem? Well, we have the Stinger.next, but we also have TES, which came out with 2.1 or Hive 13, which allows for a alternative to your batch MapReduce for the different data access functionality. So Pig, Hive, Cascading, and any other engine can start using TES in order to get quicker interactive access to the HDFS file system. TES does a lot of things. It does some DAG analysis, vectorization, things like that. So cool stuff. It allows, actually one of the things that it allows, so one problem with distributed systems is the ability to understand the data during execution. So think of, in SQL Server, you have statistics, right? So when you run a query in SQL Server, the query engine knows ahead of time approximately how many rows are in the table, how large the row is. It knows the cardinality of the columns, things of that nature. That's very difficult in a distributed environment where you may be running a query where your data is spread across hundreds, if not thousands, of servers. TES helps with that. So TES has a vertex management that allows it to get some of that size information, some of that statistical information during execution for performance. So that's just one of those things. It also optimizes memory usage, so it can reuse memory containers. Normally with MapReduce is that once memory is allocated and the job finishes, the memory is deallocated. With TES will actually hold that memory and allow that memory to be shared across processes, different jobs. Okay. So let's do a quick run over of some of the other integration So at the core of HDP, we run Embari. Embari is our operational management service. Again, it's 100% open source. So when you manage a Hadoop cluster, you'll be using Embari. And we got a lot of very interesting things coming out in the future with Embari, in the near future, including Embari Views, which will allow third parties to plug in their graphical interfaces into the Embari web interface. So Embari becomes the one-stop shopping for Hadoop management. And Embari, the development in Embari 2.1 has been it's been really great as far as the usability and the breadth of operations that it manages. So the ability to stop and start services, the ability to access logs, the ability to access different web components for the different features that are included in the Hadoop ecosystem. And then on top of that, you have System Center SCOM management packs, which allow you then to get notification and manage from an operational standpoint the Hadoop infrastructure. So here's just another look at SCOM. There are management packs for SCOM that tie into Hadoop. So security, again, we talk about one of the 5 boxes. Security is obviously a big component. At the very tip of the iceberg, we have Knox, which is a gateway security. It's the gatekeeper for your Hadoop cluster. So you set up Knox, and everybody accessing your cluster goes through Knox for authentication. If you want to dig down a little deeper, then we do have Kerberos support on Windows. So we do allow connection with your you install a local KDC, but then you connect to your Active Directory environment. So you can use Active Directory groups to enforce data access control. Now, recently, Hortonworks acquired a company called XA Secure. So we purchased this company, and then we have released the source code into open source as Apache Argus. Now, what XA Secure is, XA Secure filled in some gaps in the security. We talked about authentication, which is Kerberos and Knox, but what XA Secure then offers is central administration. So now you have a central secure point for Hive, HBase, HDFS, and we're going to start plugging in others like Storm and some other components, and they can all be managed from a single central administration console. It also provides authorization, so think of column level authorization, the ability to drop or create tables in Hive, HBase access, file access, and HDFS. And very helpful for a lot of companies is the audit control. So the ability to adhere to compliance like HIPAA and some other compliance. So if you drop a table, you change data in a Hive table, that would show up in a log, which can be reviewed for audit. So data protection, as far as encryption, we've chosen to just allow whatever current encryption standards you have in your enterprise, you can apply to the Hadoop, the HDFS infrastructure. Talk briefly about Apache Falcon. So Apache Falcon in HDP 2.1 is, I like to think of it kind of like the data control in SSIS. So it's, and it controls the data flow processing that you normally see in something like Uzi. And it will allow this movement of data, particularly movement of data from on-prem into Azure, into your cloud infrastructure. It allows for replication of data, disaster recovery, backup between environments. It can be, it can work on moving data around. So you may have a staging area, you may have a kind of a data quality area, and it can manage the data movement between those different environments. it also provides audit trail and lineage, so you can discover where the data came from, who owns the data, and that thing. So very interesting technology, and really has a lot of good things going forward. So I'd say now we have kind of a complete picture. So this is a busy slide, but this puts it all together and shows our integration with your current Microsoft investment along both BI tools, current SQL Server investments, development tools, as well as management, and then also the flexibility of the Azure and HD Insight environment. So quickly, just some information about Hortonworks as a company. So we are 100% open source, as well as we have the largest amount of committers in the industry. So this is a list of our committers. So a committer is are individuals that actually write the code for these products. So it's a little different than contributors. Contributors provide input, but only committers are allowed to write code. And we have the largest amount of committers in the industry by far, across the board. We have a full suite of integration tools along the 5 boxes. And this is just an overview and kind of what we provide in our distribution. As you see, there are a lot of different components that make up the Hadoop ecosystem. And what Hortonworks provides is the stability of putting all these different Apache projects together into a single distribution, as well as testing the interaction between these products at scale on Yahoo clusters. Currently, we test on cluster sizes ranging from 6,000 to 10,000 nodes for at least 3 months in order to burn in our distribution. And how this works as far as our open source is that we grab the GA versions from the Apache projects. We test and develop and distribute those projects, and then as problems occur through our testing, we then fix them and submit them back to the Apache open source. So we are the closest version in our distribution. We are the closest version to what is open source that there is. And anything we add as far as fixes and patches, anything we add to our distribution, we resubmit to the open source community. And we strongly believe that the open source can innovate much faster than any proprietary offering. All right. So this is just a run over of what we provide. And again, these are some additional resources. We do have a Hortonworks University, so some of you that are in the research or evaluation phase, we'd love to talk to you. We do provide very good training programs, and we always strongly recommend some kind of training, prior to a POC to really get the most use out of your Hadoop experience. If you want to play with the product, we offer the sandbox for free. It is free for download at our website. We have a Windows version as well as a Linux version, and we have dozens of samples and tutorials that you can run against it, and it's completely free and open. And finally, don't forget about HD Insight. If you already have Azure or if you have any EAP agreement through Microsoft, you may already have some Azure funding and already have access to HD Insight. So talk to your Microsoft rep about that. And here's just some other links for more information. We have very good documentation at Hortonworks at docshortonworks.com if you want to try to install your own cluster. again, training, web resources with Microsoft, and we also have forums for more learning. And finally, you do have a chance to win an Amazon card for complete evaluation, and that, Paco, that pretty much covers it.
Great. So let's have a couple of questions, and then the meeting will be finished, and you can fill the evaluation to win 3 Amazon gift cards. And if you complete the evaluation of the 5 sessions we're having, plus attending the 5 sessions we're having, you could enter the raffle for a GoPro. So let's see. One of the questions is, how does Hadoop on Windows compare with Hadoop on Linux with respect to performance?
I haven't heard of any dramatic performance difference either way. There are some extremely large companies, unfortunately I can't mention their names due to NDA, but there are some extremely large companies running Hadoop on Windows without any performance degradation.
Great.
And I actually learned really quick about Azure. I learned something today about Azure, is that there is some question about running Hadoop in Azure because of virtualization in the cloud environment. But in fact, what Microsoft does in Azure is your memory and your CPU are dedicated to your VM. So you're not sharing compute or memory in Azure. So performance, they actually say the virtualization management overhead is less than 3% in Azure.
Great. We got another question, and is, will there be any on-premise HD Insight version anytime soon? The one that I have is ancient.
HD Insight on-prem. That's a good question. I don't know the answer to that. I can track that down for you, though.
Well, so far what I've heard is that Microsoft will not release an on-premise version, and it relies on Hortonworks on-premise version.
Oh, I see. Yeah, you're right. So HD Insight really is just a rebranding of Hortonworks. So HDP. So when you get, I mean, if you download our sandbox or install HDP on-prem, that is basically HD Insight. Now HD Insight doesn't have all the functionality, and the and it used to be that when functionality came out in HDP on-prem, it took 6 months before it showed up in HD Insight. Now that's down to less than 3 months, I think, or even less than 2 months. So we're seeing a parity shift between the functionality in on-prem HDP and functionality in HD Insight in the cloud. But they're basically the same thing. They're the same code base.
Great. Okay. Well, thank you very much for attending. So right now, when you leave the meeting, you will see that there is a survey, and also you are receiving an email right now from or within an hour for filling the survey. Well, thank you very much, Scott. I hope all of you enjoy. Thank you.
Thank you.